To look at another trig equation, this one being the sine squared of theta is equal to the sine of 2 theta divided by 2. And here we have an equation where both terms involve the sine function, only the term on the left involves the sine of theta and the term on the right involves the sine of 2 theta. We need to get both terms in terms of either the sine of theta or the sine of 2 theta. So let's try to get everything in terms of the sine of theta. So what I can do is I can write this equation as sine squared theta is equal to the sine of 2 theta divided by 2, which is equal to 2 times the sine of theta times the cosine of theta, all divided by 2. And this is equal to the sine of theta times the cosine of theta. Now I'm going to bring the right-hand term over to the left-hand side, so I get sine squared theta minus the sine of theta times the cosine of theta is equal to 0, and I'm going to factor this. So the sine is a factor of both terms. I'm going to pull that out. So I have the sine of theta times the sine of theta minus the cosine of theta is equal to 0. And this gives rise to two separate basic trig equations. The sine of theta is equal to 0. And the other equation is that the sine of theta minus the cosine of theta is equal to 0, which is equivalent to the sine of theta is equal to the cosine of theta. Now, this first basic trig equation is easy to solve. We know the solutions are 0, pi, 2 pi, 3 pi, and so on. So these are just all the integer multiples of pi, which I can write as k times pi, where k is any integer. All right, so we know that these are going to be solutions to our equation. Now, the second equation over here, this one, the sine of theta minus the cosine of theta equal to 0, leads us to the sine of theta equals the cosine of theta. And in order to solve this, what we would like to do would like to write everything in terms of, let's say, the cosine of theta or the sine of theta. But this is a little tricky because we don't really have an identity to do that. So what we have to work with is, of course, the sine squared of theta plus the cosine squared of theta is equal to 1 of our basic Pythagorean theorem. And now what I want to do is I want to employ this identity to help me solve this equation over here. But in order to do that, I need terms that involve the sine squared and the cosine squared. So what I'm going to do is I'm going to square both sides of this equation. So I'm looking for solutions of sine squared theta equal cosine squared theta. Now, some of the solutions to this equation might be extraneous. In other words, I might find solutions to this equation which are not solutions to the equation that I really want to solve, this equation here, okay? But let's deal with that a little bit later. So here's what I'm going to do. I know that the sine squared of theta is equal to 1 minus the cosine squared of theta. So I'm going to use this. I'm going to replace the sine over here with 1 minus the cosine of theta. 1 minus the cosine squared of theta. And this is equal to the cosine squared of theta. So this gives me 1 is equal to 2 times the cosine squared of theta, which is equivalent to cosine squared theta is equal to 1/2 which implies that the cosine of theta is equal to plus or minus 1 over the square root of 2, which is equal to plus or minus the square root of 2 divided by 2. So now we know solutions to this. So if I look at the cosine of theta equal the square root of 2 over 2, the solutions are pi over 4, 7 pi over 4, and so on. Okay. And if I look at the cosine of theta equal to minus the square root of 2 over 2, the solutions to this are 3 pi over 4, 5 pi over 4, and so on. All right. So, what happens? Well, let's look at this solution here. All right. So this solution here, when the cosine, when I take the cosine of 3 pi over 4, I get minus the square root of 2 over 2. And when I take the sine of 3 pi over 4, I get plus the square root of 2 over 2. Okay, so I have the cosine of 3 pi over 4. This is equal to minus the square root of 2 over 2. And the sine of 3 pi over 4, this is equal to the square root of 2 over 2. So what do we know? Well, we know that 3 pi over 4 is an extraneous solution. Okay, so we're going to discard that solution altogether. And what can we say about the cosine of 7 pi over 4? Well, the cosine of 7 pi over 4 is equal to the square root of 2 over 2, but the sine of 7 pi over 4 is equal to minus the square root of 2 over 2, and so this is another extraneous solution. So we have two solutions, pi over 4 and 5 pi over 4. Okay, so these are our two solutions, and to the equation, the sine of theta is equal to the cosine of theta. And so we know that all solutions are going to be of the form, so all solutions are of the form pi over 4 plus 2 pi k, where k is an integer, and 5 pi over 4 plus 2 pi k, where again, k is an integer. Maybe I can write these in a better form. So let's look at this. So here I know solutions of the form pi over 4 plus 2 pi k. So these are even multiples. These are even multiples of pi, right? Because if I take any integer k and I multiply it by 2, I get an even integer. So these are all the even multiples of pi. And over here, what I'm going to do is I'm going to write this 5 pi over 4 plus 2 pi k. I'm going to write this as pi over 4 plus pi plus 2 pi k. All right? And this in turn is equal to pi over 4 plus pi times 1 plus 2k. Now, this term here, these are all the odd multiples of pi. So what do we have? We have that all the solutions to the equation sine theta equal cosine theta are of the form pi over 4 plus k times pi, where k is any integer. All right. And then we also had the other solutions. What were they? They were the solutions to the equation. Let me see, where was this? It was way back here. Here it is. The solutions to the sine of theta equals 0, and they're all of the form pi times k. So the solutions to our original equation are given by pi over 4 plus k pi and k times pi. Again, k being any integer, right? So these are the solutions to our equation sine squared theta equals sine 2 theta divided by 2. Okay, we could have solved this equation in a slightly trickier fashion. So a second way to solve the equation, I'm going to call it star because I don't want to rewrite it. So that equation. What I'm going to do is this. Instead of having the sine squared of theta here, I'm going to put in a trig function that has as its argument 2 theta. So what do I know? I know that there's an identity that says the sine squared of theta is equal to 1 minus the cosine of 2 theta divided by 2. Right? So I'm going to use that. Right? So there's our equation, and I can rewrite this. This is 1 is equal to the sine of 2 theta plus the cosine of 2 theta. Okay? And now let's do something else. Let's multiply this equation by the square root of 2 over 2. All right. And now, what do we know about this? The square root of 2 over 2, that's actually equal to what do I want to put this in terms of? 1 second here. I guess it doesn't matter. So this is the cosine of pi over 4 plus, oh, and this is I'm forgetting something here. This is very important. There's a 2 there, and there's a 2 here. So those terms are missing. That's what I didn't like. 1 second. Okay. So then here I have cosine 2 theta, and then this is the sine of pi over 4. Now does this look familiar? Well, this is equal to, the sine of 2 theta plus pi over 4. So this is one of those additive angle identities. So to solve these equations, we have to use these identities. Okay. Well, okay, so I'm looking for some angle such that the sine of that angle is equal to pi over 2. What do I know? Those angles are going to be pi over 4 and 3 pi over 4. All right, so again, the sine of pi over 4 is equal to the square root of 2 over 2, and the sine of 3 pi over 4 is equal to the same. So that tells me that this angle in here, let me do that in red, this angle in here is such that 2 times theta plus pi over 4 is equal to pi over 4 plus 2 pi k, or 2 theta plus pi over 4 is equal to 3 pi over 4 plus 2 pi k. Okay? So this tells me that theta, so I have two equations sitting here. The first one tells me that theta is equal to pi times k, and the second one tells me that theta is equal to 2 pi divided by 4 plus 2 pi k, which is equal to pi over 4 plus I'm sorry, just thinking, pi over 4 plus let's see, what did I want? This is this. Okay, so this is going to be pi over 4 plus 2 pi k. But this has to be divided. That was the problem. Sorry. I knew there was something wrong. I'm trying to do this all in one step, and I'm failing. Sorry. So I'm going to go back here. So we're looking at this. This is a 2 here. That's what was missing. There we go. So this implies that theta is equal to pi over 4 plus pi k. Okay? Because I'm dividing both sides by 2. And now we're getting our solutions. So the solutions are of the form theta equal pi times k and theta equal pi over 4 plus pi times k, where k is any integer. And this is exactly what we found up above. So these were the solutions that we found up here. somewhere. Let's see. Here. All right, so the two techniques agree, but they're really different approaches. All right, so let's end our lesson here, all right, with these